Hey guys, and welcome along. So in this video I'm doing something a little bit different. You remember that Pcbway 728 I was doing and I had a problem with the clock on it? Well, I've got something to try and help me to see if it's working. So grab yourself a drink, a few snacks and a comfy chair, and let's get on with it. So guys, going back to what this video is going to be about, a recap is that I had this 728 that had been damaged in the power side and the voltages were put through to the board on the 5 and 12 volt rail, gone through, and if you want to check up on the other videos on it, slowly tracking down and replacing all the components. Now I've got to a point where just about every IC has been replaced on the board, and I'm still not getting the correct clock for the CPU to run. Now these boards work in a way that they use the TMS 9928 video processor, and what that does is you supply that an 11 point, I can't quite remember, megahertz clock, and internally it divides by 2 and divides by 3. So the divide by 3 then comes out, goes through a couple of inverters and goes to the Z80. So this should then give me around about a 4 megahertz clock, but it's not. I'm getting a 440 kilohertz clock, not megahertz. And I have tried 5 different TMS 9928s, and I've even tried a TMS 9918. And they all give me exactly the same. So there is something else causing this problem. So thinking about this, I decided, why don't I design a clock generator and it can be divisible? So I looked around the web and I found some guy who made a basic Z80 board with a reset and a clock generator that was divisible down to what you want, and it will divide up to 10 times. And I thought, it's pretty cool. So I didn't need the Z80, so I took the circuit and reworked it, and I left a couple of things off the main one. So I'm now to version 1.2, and this gives you a 5 volt input, and I'm using a 57 megahertz crystal, and what that's doing is, through the ICs, it's allowing me to divide it down to up to 10 times. So I can either go full noise, which will give me 57 megahertz, or then the next one divides it in half, and then the next one divides it in half again, and in half again, and half again, and all the way down. So in the middle, I'm getting my 4.6, I think it is, megahertz clock, and that's what I need to have around about. That's where I'm up to, so I will show you this. And also I left on it a reset circuit, so if you want to try and do something with the reset on the board, this will give you an option to do a reset with the 5 volt side of things. But anyway guys, I will take you over and show you the board I've done and that, and the project is on Pcbway under shared projects. If you want to have a look at it and think you might want to make the boards, you can jump up on there and have a look. So we'll just switch over cameras now and I'll take you on the rest of what this is. Alright, so see you shortly. Right guys, so from our friends at Pcbway, I ordered the boards, but I actually have 2 sets of boards. These ones are for the Pcbway cartridge, and these are for the Pico ROM. You can use the Pico units and put them on here, and I think it's just a diode or something they need, and you can upload ROMs and stuff to them and play them on your Pcbway without having to worry about the ROMs themselves and that type of thing. So anyway, that is actually on GitHub, and I will put a link in the description on those. While I was ordering my boards, and I will take you on a thing to Pcbway and show you that online, but these are the size of the boards. They're only tiny, guys. I made them tiny because I only wanted it so I'm going to take the pin out on the graphics processor and take the clock off this board and put it back into the system so that that clock will then run through to the processor, and hopefully the processor will run. Now the other circuitry is on here. Someone asked me what's the 555 timer and all that for. That stuff goes along with the reset switch, and that is for doing the reset circuit. You push the reset button, and to reset a Z80 processor it needs so many cycles before it can kick off again, and that's what the timer does. The timer counts down to give you that time. These boards I have on here what the dividers are on them, and on here it's using the 57 megahertz clock. It tells you what frequencies it's running. You can change the crystal to whatever you like. You can put whatever you want in here. I did that because it was the best one I could find for the frequencies I want, and this is the dip 8. You could probably work in a dip 16, but I couldn't find any in the frequency I wanted, so that's why I changed it to a dip 8. And I mean, I could have put a dip 16 on here, the standard ones, but it's just room on the board, and I wanted to make these as small as possible. The other thing to think of, guys, is these boards. If you go into Pcbway at the moment, you get 10 boards for $5, or it used to be 5 boards for $5. But if you actually go in and have a look, you get 10 boards for the same amount. The postage might be fractionally more, but you get 10. I'm going to list some of these up in the community section on my YouTube, along with these and some other boards I've had built that I've got extras of. And if anybody is wanting any in the local, within New Zealand or in Aussie, that wants to pay for postage and a couple of bucks towards the boards, I'm more than willing to post them out to them. Alright guys, so I will now take you to Pcbway and show you the project, and you can actually see what I'm doing. Alright, so hang on and we will switch over. Okay guys, so here you can see my uploaded page on Pcbway, and these are the projects I've put up at the moment. So I have on there the 8-bit CPU clock board that I'm just about to show you. I have my Dragon 32 power supply and video audio replacement board. I also have my Z180 system board that I designed with some inspiration from other ones on the net, and that's an ongoing project I haven't finished yet, but is part of the way there. And the other one I've got is the redesign of the Mac Plus SCSI internal controller, from one that I had in a machine from quite a few years back, and it wasn't completely on the board. It was using cables all over the place, and I wanted to streamline it down to a standard board where all the cables go to and then the others come off of. So that's where I'm up to. But anyway guys, we will have a look at this project now, and I'll just switch it over. Right guys, so here we are. This is the project, and this is the board. That's a close-up shot that they put in. Why they don't have an option that auto adjusts it to fit, I don't know. But this one here, as you can see, this is the board as it is now. It has a clock output, and the reset output is over here. So what you can do is you can use that reset to reset the CPU if you put it on the reset line. So it's easier for doing things like that if you're working with development boards and things like that. So if you're building something up and you don't have a clock for it, you could put this in place and get your clock and your reset off that one board. And that runs 5 volts. So if you wanted to, the other option I thought I might do if I do a revision of this is I might put a through pass for 5 volts. So you can take off a 5 volt connector and feed it to your development board as well, because this just uses the 5 volt in. Now it is only 5 volt DC in. I have not put any other regulation on this board, so just be aware if you're pumping more than 5 volts into this, you may damage stuff at the other side, so just be very wary of that. As I said, I might look at if I redesign this and make it a little bit bigger within the 100 by 100, I could then look at putting in the footprint to put either or of the clocks on here, and that'll be for the 8 pin or the 16 pin form factor. So I can put those on there and put on a header for the 5 volts out and put some form of regulation on the board, so resettable fuses and things like that on it, just so if you wanted to pull off 5 volts you can do. And just remember guys that the numbers that are on this board for the frequencies out is only dependable on that 57 megahertz. If you want to get other ones, you can put different crystals on there and just do the division by to tell you what it is. So you can do whatever you like. And I mean, in a later version board, I might actually put a piece on the back with blanks in the different divisions, so that you can write them in with pen to what they are, if you want to, with a felt pen or a non-removable marker. So that might be another thing I will do later on. The only thing is I built this for me, for what I needed it for. So it's not being built as a project for selling or anything like that. So if you want to get them made at Pcbway, I would be very appreciative if you did them off the link I have here for the shared projects. It just gives me a couple of cents, 20-30 cents or so for you getting the boards made there, and it actually helps me that if I want to do more projects and make more development boards and things, it covers the costs of making them and then having to get reiterations and that, because these boards are the Mark 1 boards, and there are a couple of things that are not on these that are actually on the Pcbway website version. That is actually the version 1.2. Alright guys, so that's the project. There are all the pictures are on there, so you'll have the front shots from the CAD, and I use KiCad for doing my CAD work. I don't see the sense in paying for something if I'm only doing sporadic work with it. I'm not an engineer and things like this. I don't need a paid service. So these are on here as well. You can go through and look at all those. All the Gerbers are uploaded. The position files are uploaded if you want them to be pre-built in Fab at Pcbway. And the generic components. There is the CSV for all your parts are on there, and all the other bits and pieces that I can think of that needed to be uploaded there, the drill files, all that sort of stuff. So everything is up there if you want it. There's a bit of a spiel about the board, and as I've put in there, there is a revision 1.1 I first put up because I actually forgot to put the pin out for the for a ground post on there, because there's somebody who was saying to me, oh, it would be nice to have a ground post so you could run the ground and whatever off it. So that's on there. And then when I was doing that, after I'd done that one and that, and then I was working out and I was thinking, where do I get my reset from? And I'd actually forgotten to put the pin on for the reset, so that was a version 1.2. So that one's on there now. So guys, that is it to there. If there's anything you'd like to see on there, that's fine. I mean, you could redesign this board back into what it originally was, which was a Z80 board with the reset and the divider for the crystal. But I don't sort of see the sense in that. I know what I want to run my Z80 at. The other thing is with the circuit you could get a higher speed of 20 megahertz or 8 megahertz Z80, and with this board you could then speed the chip up. So you could put a 20 megahertz Z80 in your board, and you could slowly increase it from normal speed up to see what happens to the system with the faster speeds, and find out where you can push the system to. So if you like playing around with things, that's the way to do it. Alright guys, so now what I'm going to do is I'm going to go back to the board and take you through putting it together. And once this is all together, then we can look at having it work on that 7 to 8 to see if it fixes our problem. Alright, so we'll switch back over to the other camera. Right guys, so that's where we're up to, so I will move these away, and as I say, I will list the boards that I have spare up on there, and I do have a few others. There's I've got some of these are for doing the hard drive backup boards. These were for the MFM hard drive emulators that uses the BeagleBone black or green prototyping microcontrollers on them. So I have some of these boards still left. I think there's about 5. I think there's about 5 left. And I do have the ones for the Z80 board. The Z180 board. And I do have some for the Dragon 32 as well. So they'll all go onto the community page. And as I say, if they're just 100 by 100 boards, they'll only be like a couple of bucks plus postage if you want them. If they're these bigger boards and they're over 100 by 100, I'll have to have a look at what the cost was, and you're only going to pay me what the production cost was on per board, so that and postage if you want them. Alright, so they're not going to be overly expensive. Alright guys, so I will sort that stuff out, and I'll put these away, out of our way, and we'll get on to the components for this and putting this together. Alright, back soon. Okay guys, so I've got most of the bits on the bench here. The only thing I've got to get is the barrel jack and the reset switch, and I'm not going to use the reset circuit at this stage, so those two bits I can put in later. The power for the barrel jack, I am just going to put a couple of wires and run it off my bench power supply, so I'm not going to worry about that for now. And you could do that, and I might look at that later on as making it an option to whether you put the barrel jack on or whether you use just a set of connectors to put your 5 volts in. I just sort of thought a barrel jack because most people have a 5 volt power pack kicking around. I'm going to do that. I've got all my bits here, headers and so forth, and ICs, and that's the crystal. That's the most expensive part on this board because it is not a hugely common one. This was off AliExpress, so I mean it was like about $4 or $5 or something, compared to the other ones you can get about 10 or 5 or something for the same price of the other types, but they are lower frequency. And as I said, I wanted this for a specific job. You can do whatever you like with it. You can put whatever crystal you want into it. Alright, so I'm not going to worry about sockets. These are all going to get soldered into the board. I do have spares if they die, so there's no big issue there. And we will do that. The thing to remember with the crystal, I haven't put a pin 1 on it, but it is generally the square hole on the board is your pin 1. Okay, so just remember that. Alright, so I just got to grab myself a 10 UF. I don't need it because I'm not using the reset circuit, but I might as well put it in because I have them. And as I said, just the switches, I'm not 100% sure where I've got my box of switches. And I bought a pack from AliExpress, it's about that big. All different heights in them, push buttons, standard ones. And yeah, I just buy those. They're just cheap, and you get about 5 or 10 of each type in it. I got them for another project that we're going to build on here later on. But that's to do with the Coleco Atom, and it's an atom net, so we are going to build one of those. And I will dig out that cap, and then we'll carry on with this. And that's it guys. I mean, I buy the packs, caps and that. I mean, you can be hit and miss with this stuff, but if you've got a component test, you can stick it on and check a couple of each and just make sure they're within spec. Most of these have been pretty good. If I'm doing anything really crucial, I will go online and buy 5 or 10 of a specific brand that I want and put them in if I know it's something like this. I mean, if the capacitors go bad in a year or 2 years, I replace them, you know, or build a new board. So the only thing I might put a socket in for is the crystal. I'm not 100% sure there, but I think that might be a good way to go. And yep, so that's it. So we've got our capacitor there. I'm putting a 25 volt one in. That's the smallest voltage I have in these electrolytics, so that's what I've done. Alrighty, so we've got all this here, so we'll start going through and assembling this thing. So guys, don't forget you'll need to realign the pins on your ICs, and these handy little tools I've been telling you about that are in my tools section playlist. There is a link to Thingiverse for these. That's for doing the small ICs. There's this version which is for doing the larger ICs, and then the other handy tool is this, and this is for bending your legs on your resistors to the right width that you want. Now these are all 3D printable files. They're all free. They don't cost you anything to download. And if you don't have a 3D printer, if you've got a mate who's got one, just get them to print you up some of these. So they are handy little tools. So I'm going to start with putting the ICs in first. And as I say, you just bend the legs and they just pop in real easy. So what I generally do is put something on the side, and it'll either be a bit of tack, blue tack or something like that, but generally if it's only one or two ICs, so we could probably put the pair of them in there. That's the 555. I'm just gonna, because the other thing you got to realise too is your ICs sitting in drawers and that, if they're not, even if they're in static foam, you may find that the legs get a bit knocked around as well. That's a 555 and goes in there, pin 1, yep. And then what I do is then I will try and because I've got the two ICs fairly well spaced apart, I can actually sit the board on top and that'll hold it fairly level for me while I tag the legs in. If you wanted to, you could throw a bit of solder on the board. I mean, you could throw a bit of flux on the board. But this being fairly new, shouldn't have any issues with it soldering. Those two are tagged on. Those two tagged on, I'll just finish soldering these up. Right, got those two on there. So the next thing I'll do is put the resistors in. I've got 10k, so we've got a couple of 10k's to go in. And these are quite soft legs, so. And that's what I say, so you take your component and depending on how far apart you want your legs, you just drop it into whichever size it is. So this is about close to the one I need, and then you just fold them down the sides of the leg spacer, and then they pop out, and that gives you nice square legs that then should pop in. Now I think this is the right size. If it's not, we just need to go the next one down. Yeah, it's a little bit wide, so we need to go step the next one down, so that's cool. So we can go into the next one, put it on there, and then we can just rebend our legs. These are fairly soft metal, so they do bend quite easily. So just bend those down and pop that out. I mean, you don't have to worry about doing this. You can always just hand bend them and put them in, but if you want something which looks a bit neater, that's an easy way to do it. And then we just slightly spread those so they don't fall out. Do the same to this one. So that's that one there we want. Put it in there, bend them down the sides. Use your fingernail or your thumbnail if you want to give it a nice crisp corner. Pop it back out. Stick that one in too. Yeah, we just splay those out fractionally, and we get the 470s. And this is the good thing, if you splay them out a little bit, they're not going to fall out of your board. We get 470s, we need 2 of those. And as I say, I don't need these in the board because I'm not going to use the reset at this stage, but I will probably use it at some later date, and then it's good to have it there so I don't have to try and make a separate reset circuit. And that one and that one, and we'll just pop those back out, and we'll put those ones in. So we've got a 470 over here, blow those out, and a 470 over here, and blow those out, and there we go, guys. So we got our resistors in there now, so we will go through and solder those up, and then I'll come back and we'll put the caps in, and we will then put the headers in. Now I've got a coloured header because it's a black board. I thought I'd put a coloured header for the jumpers, and I don't know whether I'm going to use just cut off these separate coloured pins for the reset and the earth, or whether I'll use the black pins. I'm just not 100% sure, one way or the other. Right, so those are all in. I'll just get my cutters and just trim the legs off. If you want wires for bridging things and stuff like that, you can hang on to the legs. The thing is though, guys, is resistors are so cheap, and you can always just grab one out of the drawer and use the leg off it. They're not a high price commodity, not if you buy them through AliExpress or somewhere like that. They're cheap to buy. You buy them by the hundred, so yeah, it's not a, as I say, they're not an expensive item. Alright, those are all done, and the next one will be the caps. Now that's the 6, I guess. It's 105, so that's the 1. Yeah, one there. And all the point ones are just decoupling capacitors. Probably don't need them, but I think at the higher frequencies we probably should have them on here. Let's see, one more. So there's 3. There's one on here for each of the ICs, and there's one on here for the power supply as well to help filter the noise out. So those are all on there. So the only different one out of all these is the 1 UF over that side. All on, we just clip those legs off. Those are all on there. So the next thing I think put on is I'll look for a socket, I think, to put this on, because if I ever decide I want to change the frequency, it just means that I can just replace the IC. I'm pretty sure that's the way we go. So the other thing to look at on your crystal, if you're not too sure, the outline on the board has 1 square corner, and if you actually look at the chip where my thumb is, that corner is actually square, not rounded like the others. I'm not sure if you can quite see that, but yeah, so that one there is actually a square corner, so that lines up with a square corner with the square pad on it. And that's just because the one in this corner, the one in this corner over here is ground, and that's your output pin. So alright, so just remember that. So that goes in there, and it'll say, oh, there's one cap there we haven't soldered yet, which we will do. An IC socket, an 8-pin IC socket, and put that in. I'll be back in a sec. Right guys, so I've got an 8-pin IC socket here. Now the problem being is there are only 4 holes on the board, and there's 8 in this. So what you can do, you can get your pair of side cutters, just the 2 center ones on either side, just grab it and just gently push it back into the socket, and they will pop out the other side. Just like that. So it takes them out, because if you don't take them out, you'll have to bend them, and then if you're short on anything, yeah, it could cause you problems. But if I just remove them, it's only an 8-pin socket. They are quite a few of them. If you haven't got an 8, get a 16 or an 18 or something, standard size socket, and cut it down. Cut it so it's 8, so it's 4 either side, and then that can just sit down into here, and we can solder that in and plug our IC in on the top. So same thing. I find this something like one of these is really handy, because you can just get it and sit it on the top to hold it there while you turn it over. And then you can just tack 1 or 2 sides and make sure it's square. Solder it in. Cool. Got one side. See, it's not sitting down flat, so we'll push it down. Tag that side. Yep, that's pretty good. So with those tagged, they're not tagged very well, so I'm going to solder the opposite sides. And that just means so that if I try to solder one side, it doesn't come undone and move on me. Yep, that one's done. So the only other things I will have left to do on this is I'll have to put a couple of wires on for the power, so I can run it off the bench power supply. And the other thing I will have to do is put a wire on it for the output and the header block on here. So I just have to trim that down. It's 1 row too long. I might be able to use those. If I've got to cut it off, I might as well use those. And I've got to put that cap in too. So yeah, I mean, this is 2 pins too long, so if I cut the 2 pins off, then I can split those and have them as 2 singles, if I can find them. Maybe not. So we'll put that in there. So that's our header pin. So I just need the one for here for the clock out. I haven't got the transistor out for this yet, but I have them up there. And so the capacitors in there, and then the 2 wires up here for the power. So I'll turn that over, and hopefully, yep, I think that will hold that up, so I can tag a couple of those legs and then solder them in. Yep, those are all done. Right, so one for the output. So I'm gonna, the red one has a single pin on one side. So clip this one off. And I'll put that one on for me clock out. You can make them a pin or a socket. It's up to you what you would want to. Come here. It's up to you what you want to put in there. So it depends if you want to have a pin sitting up so you can tag a wire onto it, or whether you want to put a socket in there and have something on it. But I sort of thought if you had you could use DuPont type connectors on it. How you can get the ones for doing prototyping boards. So something like that could do the job. Oh, and he fell out. That's the problem when you try to do these with the single pin ones, is they do drop out. I should have put a right angle or something in there, I think. That would probably have done better than mind you, I suppose I could do have it coming off outside. If I put a right angle one in, at least it's poking off outside, eh? Yep, that's in there now. Right, so that's got those all on there, and as I said, all I need to do is to tag a couple of wires on here for power, which I will do. Those can go back in. I mean, you can use singles if you like, cut them off and put singles in. As I say, they're just a bit tricky to get on here. So the only thing I'm missing off here is the reset, which goes between this resistor and the transistor here, but I could always tag a pin off up over here to solder onto that resistor and up. That'll give me the reset line, and for a ground off the side of the earthing on this, I can actually put a pin underneath here, get a right angle one for a ground if I need to. But I'm not going to use the ground anyway. The reset, as I said, the reset is I'm going to do this. Put this on. The reset is just for resetting a CPU, and I mean, I don't know if I'm going to need it, but if there's an issue with the 728 with the circuit, then it would be handy to tag it into the reset line. So the whole thing has a purpose then. That's cool. That's done. Clip the legs on that one. And when I've finished all this, I'm going to give it a good clean up with isopropyl as well. So those are there and there. So I might tag a pin onto that resistor on the back of this resistor here for a reset pin. Let's put a bit of solder on this first. A bit of solder on the iron. And because the bend that up a bit so it's straighter, just that it gets a bit hot to hold, that's all, while you wait for it to solidify. So I might just do that with that. And then that just gives me plenty of room to do the transistor when I want to. Yep, that's fine. So that's my reset. And as I said, a ground, once I put something in here, I can pull ground off of this. My ground plane is the bottom plane, my power plane is the top plane here. So this back pin is my plus, the middle pin is my ground, and the same as, I haven't done it, but these outer ones should be set to ground as well. But they're just mounting, they're for stress relief, so those are my two main ones. So let's get a wire now, and I'll have a hunt. I've got some red and black wire, and it doesn't draw a lot of power. I'll just get a wire for doing that and attach that on. Then we can give this a good clean, and I'll put some double-sided tape, or I'll put it on some anti-static or something just to hold it up off the board so it's not going to short on anything, and we can go from there. So how you use this thing, guys, yeah, this is another kit you can get off AliExpress, is the header pin jumpers, and this is one that has the long ones, the tall long, extra long ones, or it has the standard short ones in it. That comes in as a little kit, different colours. So I've just got a tall one so it's easy to pull on and off. And the way this works is that when you look at this board, if you jumper it as full, that goes on there, you're getting the full 57 megahertz out of this off the clock. If you drop it down to the next one down, it's divided in half. So therefore then you're getting 28.6 megahertz. You take it off there and drop it the next one down, then you're getting 14.25 megahertz, and so on all the way down. And if you do it on the very last one down the end here, you're going to get 222.6 kilohertz. So quite low. But the one I want is I've marked it in the middle there, which is divided by 16. And what that one gives me is that gives me the 3.56 megahertz, and that's very close to where I need to be for the CPU, and I think it's 3.567, something like that. So it's within a few hertz difference, so that should cause it to run fine. So that's where I need to be. And the thing is, as soon as you put power onto this, I haven't put an on-off switch on it, but as soon as you apply power to it, it's running. So just remember that. As I say, in a different iteration, you could probably put a power on-off switch on it. The other thing you could do is, because I'm running off my bench power supply, that has an on-off switch with a power out on it. I don't need to worry about a switch on this board. But if you need to, you could probably put a switch into it. If you're not going to run a power jack, you could probably put a 3-position switch on it and then run one side. Yeah, up to you. So I will clear this lot away, and I'll find my piece of wire, or pieces of wire to go in for the power, and then we'll be back at this. Okay guys, so I got my bit of wire. So what I'm going to do is a little bit fatter than the holes. So the top plane of this is positive and the bottom plane is negative. So I'm going to solder them onto this one onto this top pin pad, and then I'm going to solder the other one to the bottom pad, which is the ground plane. Cool, so that's all done. The other couple of little components, I can probably dig out the transistor, and the reset switch, as I said, is the only thing that I'm missing at this stage. But it's not something I need to worry about. I mean, that part of the circuit will be just running anyway. So I'll dig out that 3904 and drop that into there. Okay, have my 2N3904, and it'll only follow the pattern on the board and put it in that way. Put it the other way around and it's not going to be happy. You just need to splay the pins a little bit for it to pop down the holes. And it'll just pop in. You can push it down as far as you want. You don't need to go too crazy with it. And then I'll just solder that in. Yep, it's all good. And that's just about everything done. So all I need to do to go to use this in the circuit for the 728 is I just need to power it up and sort out a way of injecting the clock signal into the computer. And if I need to, I can pull a ground off of this as well. or off the top here. I could put a ground pin on here. And that's it done, guys. So that's how simple it is. So if you want a nice little easy clock circuit with a reset, and as I said, this has been changed slightly so it has the option for that. If you want to be able to have power through on it, let me know and we can rejig it and go down that track. We can even, you can get those little, no, you can even get these little blocks, and these are solder-in blocks that had the screw pins on them. So we can even get these, and we could probably put something like one of these into the board. It's just the problem I have with this sort of stuff is that it starts making it bigger and bigger and bigger, and then it'll get to the point that like that's almost 100 mil. So it's going to make it, you know, and then you're going to get so big, and then it becomes clumsy as well. So that's the other thing. Alright guys, so anyway, I will sort this out and tin this end of the power wire. So when I use my power connector and I clip onto those, it's all good. And I'll put give this a clean up and put some double-sided tape under it as well. We'll leave this one here and we'll pick up with when we get back onto the 728. So guys, there we go. What do you think? Cool little bit of gear, isn't it? So, and as I said, you can change that crystal to give you the different frequencies you want to be dividable by. So if you only want to put a 20 megahertz in there, you go 20, 10, so on and so on, down to even lower frequencies. Or even if you dropped a 10 megahertz in, again, you'd go down lower frequencies. So I think it's actually quite cool and a handy piece of gear. And that has the reset circuit on it. If you're testing older CPUs that have a reset line to reset the processor and it's not doing it itself, you can use that to reset it to see if the circuit runs fine. And if it does, then you know there is an issue with your reset circuit. Alright guys, so that's where I'm leaving this one. And I can't guarantee the next one up is going to be the 728. It may be something else, but we are going to get back to that, and I want to have a look at it. The other thing I've done is I've pulled out my 728, which is running as far as I know. So if we still don't have any joy with that clock circuit, we can do some comparisons between the two of them to find out why. Anyway guys, that's enough prattling on from me for this time, and as I always say, you have a great day, have a great week, and until next time, ciao.